Hey there, fellow sound otakus. I'm back with another video showing the progress of this particular location involving a stage play. So here we have the lighting controller for the rig, and there it is. There's the stage design. I'll get you a wide shot directly shooting at it in just a second. But wanted to show you also what I've been working on, as there are two stage props that have LED strips in them, and I've had to put them together and also wire them. So there's one of them that's going to be a little box that's on the left, and I'm going to bring up red, green, blue, and white, as I also need to test it to make sure that it's working. So the first thing I need to do is actually select that particular box and then get the parameters set. Okay, so here we go for red, and red is working. And then green is working. And it looks like the lighting for the house lights are changing too. So let me clear that out, set it back right quick, and make sure that those are deselected. So that group is deselected. Okay, so if I do green and blue this time, there should be no change. Yeah, no change in the house. So there's blue, and then there's white. Okay, so that's working. So that is verified, and I'll get you an up-close shot of it soon. But for lighting, there's about anywhere close to 125 cues that are in this particular play, which is not bad. Next item, which is over here, this is where I sit and I operate for audio, and then I handle the second set of tracks. So I handle house music during walk-in and intermission, and then I handle some sound effects also, to where there's also music that also has to be there at the same time. This is the main audio console. We are running about 23 mics, all wireless. So I actually did a frequency coordination of all that, and here is the actual map of it. So each of those spikes that you see there is actually the transmitters sending out their RF transmission, which stands for radio frequency. And as you can see, this is Wireless Workbench. It's made by Shure Incorporated. So as you can see in all of these particular ones, so the blue representations are that is the scan in the spectrum between 470 megahertz and 533 megahertz. And then let's see. And then we had a pink one that was actually taken out, but that was for the frequency range. Actually, no, it's over to the right a little bit, sorry. So this is between 534 megahertz and 598 megahertz. So that's pretty much the entire 500 megahertz spectrum. And then the orange one is one that I did earlier. It doesn't have to do with the play, but that's actually the inner monitor systems. There were some that were just a little bit too close to each other, so I actually spread them out. But this is just the measurement that was taken. The transmitters for those IEM systems are actually turned off right now. Pretty much any wireless that we don't need at the time, we turn them off. But in many cases, they should not cause an issue, but every once in a while, you may get some intermodulation. But ultimately, I made sure that all of the wireless transmitters are spaced out so they don't basically get jumbled up between each other, because then you can run into interference issues, which can cause some problems. So we did 2 out of 4 shows so far. And on the first show, there were some problems with some mic cables that connect the microphone to the transmitter. So those cables have been replaced, and it sounds much better now. This allows me to monitor about 14 of the 23 mics, because their receivers have a network port on them, and then they can be interfaced into Wireless Workbench. The other 9 transmitters, basically I have to look at my metering, which I can see on here. so I can look at my metering and see what's going on with them. Basically, I only look for signal deflection. That just lets me know that they're on. And I also look for if there's any major peaks in the metering. If I see that there's a major peak, then I know that I've probably got a wireless problem, less likely, but most likely probably a cable problem with that particular mic, or in this case, because the actors have to wear masks due to certain health regulations right now, it may also be that the mic is probably rubbing against the mask. But we've got it now to where they pretty much won't do that. The only other issue we may have is wind, where sometimes if they breathe heavily, maybe some of that air will escape past the mask and it may blow past the microphone. But we've also got windscreens on the mics, and we've also got it to where it's kind of at a perpendicular angle, so that way the air kind of gets rejected from the particular microphone's cardioid pattern. No, I'm sorry, I think they're omnidirectional, but still, that's okay. We've actually had good performance with them thus far. So just taking you around, and let's head over here right quick so you can just see the transmitters. So these are some of the Shure transmitters, and they have rechargeable lithium ion batteries in them. And if you notice, we've got some straws on the transmitters. And no, this is not a Stage Blaze specific design. This is actually to decouple the antennas from touching bare skin. Because as I've read in one article, the antennas touching the bare skin can actually reduce RF performance. And we actually had some cases of that during rehearsals. And especially on these particular packs, the antennas actually are not straight. They're actually very soft, and they actually flop over a lot. So the tip ends up facing downward. So to keep them straight and to make sure they don't touch skin, we've put straws on them. So I learned that trick a while back, and it actually works very well. And these are the belt pouches for all of our actors. So the number corresponds to that particular microphone, which is also adjusted related to their waist. So if we get a nice little shot of the stage, this is actually the walk-in setting. So you might not be able to see what it says on the screen, but it basically is the title slide, Willy Wonka. And then on stage right, we have kind of a light blue or almost a light violet color on the washes. And then on the stage left side, we've got an orange color wash. And then for our other lights, we have a gobo that kind of gives you kind of a hex pattern. So it's pretty cool. And then also we've got the LED strips for our stage prop that acts as an elevator and kind of like a fortress type of prop. So that's kind of cool. And what I'll do is just turn on a light right here so you can see in the back. So I'm just going to move this back right quick. So this is the machine that actually powers the LED. So this is the power supply. Then this device up here is the Dmx Decoder. So like I had mentioned in a previous video, Dmx, which is digital multiplex, the channels and values that is sent by the lighting control unit, the specific information for these LEDs is sent to this device, and then this device takes the power from the power supply and then applies as much energy as the lighting controller tells it to then send power to the LEDs. Now, the way the wiring is back here, each wiring set represents an LED strip. So on this particular stage prop, there are 3 LED strips. One on the left, one in the middle, and one in the right. So left, middle, right. So the way it works is there are 4 LEDs within the strips. So it's red, green, blue, and white, which kind of is the same as this particular color scheme here. The black one is actually the common. So what that is that gives a return path for these 4 for the electricity to come back. So to get the different colors, you can actually mix intensities between these 4 colors, and that'll get you pretty much all the colors that you usually want. I have yet to experiment to where you can actually get brown though. So if anyone sees this video, if you can put a suggestion in the comments on where that is, what color mixing is for brown. We don't need it. I'm just curious about it. But then that comes down through an umbilical cable, which is basically all these three cables bunched together. It's basically power and then DMX to the fixture and then DMX out, which then goes to another decoder, which controls this thing. So this is the small box for one particular scene in Willy Wonka. So this is all one circuit, as you saw in the demonstration. So wiring comes from here, then it's wired in series from here to here, then from here to here, and then from here to here. Looks like the electrician's tape is coming off just a little bit, but that's okay. So what I did for this particular wiring scheme, here's the power supply and the decoder for it over here, and that's segmented to the corresponding DMX address. So what I did for this particular scenario is I took outdoor grade Cat 6 Ethernet cable and then wired up for a quick disconnect right here. This is one of the Panduit connectors, and then wired that in via this connection right here, which then I soldered the connections from one smaller gauge wiring to a larger gauge wiring, and then that can be connected and disconnected via this. I had forgot to get some tab protectors, so I actually used electrician's tape to actually make a tab protector, so that way when they disconnect it, the tab doesn't get damaged if the cable were to snag on anything. And then I use some, this is not double-sided tape. This is actually a material that I found on Amazon, and it is a strip tape that they claim is reusable. So I actually have also this material in my studio that I use to put the acoustic treatment foam padding on. So apparently you can pull this off, you can wash it or rinse it off and then allegedly reuse it. I have yet to test that, but if I ever get around to that, then I'll let you know. But this turned out to be a very great solution. Maybe in the future I'll do EtherCon instead of just this, but we didn't have time to get any. But overall, that is this particular show. So, hope you enjoyed this video. And until next time, happy mixing, everyone.